never this hard before. Transformations. Does the camera still running? Yes. Did I say that already? Transformations. And when you see transformations, no, I see the thing's working. It's going back to being a bad day. When you think transformations, you should think of the way shapes go from one place to another, and that's the technical definition. Hold on a second, I'll give you the exact one here. Operations on a geometric figure that alter its position. How about that? How about just saying moving a shape? Would that work better?
Yep.
Moving a shape. And what that means is this. Let's say I have a shape, and I am going to use a right triangle if that's okay with you. I don't really care if it's okay with you, but I will use it. Let's say I've got this right triangle. How do I know it's a right triangle? Mostly because it said it was a right triangle. One way that you can move a right triangle and put it to a different place is this. You can just take it and do that. How about that? Which means, we do little arrows here to show that. Oh, look at somebody just. Okay. Which means we could slide it. But obviously, ladies and gentlemen, boys and girls, slide does not sound mathematical enough. So somebody had to come up with a mathematical word that means slide. Notice it didn't turn, spin, do anything there. It just went and you kind of dragged it from one place to another, to which Maddie Marco is going to say that yes. The real word that we have to use in math is a translation. You want to impress your whoever, say something was translated from one side to another, you have to use the word translation. Got that? That's a pretty simple one. If your shape did this, don't yawn. It doesn't make the teacher feel very happy. If the shape did this, come on, you. Oh, I am a trained professional. Come on, you over here, though. If it did this and kind of did pull one of these little maneuvers where it turned, or if you turned or spun it, again, not very mathematical words, so we have to come up with something a little bit better than that. If you turn it, what are you looking in your book? Maddie, it is a
Rotation.
very good rotation. That's one of the three transformations we do. You can slide it, you can turn or spin it, or translate it or rotate it, or the third thing is, and I'm not going to ask Marco, she is looking at her book. That really didn't end up being too well, did it? I'll just do some of those. This one is this. If you take something and it gets this, I like to call it being flipped. But flipped is not a mathematical word, so we call that, Emily?
Mirror.
Yeah, it's mirror too, but that's still not mathematical enough. A mirror image of it. Aubrey?
Reflection.
Yeah, it's a reflection. So those are the three different ways that you can transform things, and you need to know their mathematical names, not our little names. So you can either translate them, rotate them, reflect them. those are your three different objects there. Now, in addition to that, we also have to throw two other words in there, and those are these. A dilation, something can either be dilated or it can be contracted. Mostly dilated, I think. What does dilation mean? Or dilated? Any of you been to the eye doctor? Sometimes they put those drops in your eyes and he says, I have to dilate your eyes, Isabel.
Gets bigger.
Yeah, then it expands so he can see inside your eyeball. And when you think of dilated, you have to think in proportion, like a balloon again. It gets bigger together. You know, one part of your eye doesn't get bigger, it doesn't make an oval or whatever. Contracted means get smaller. Something's contracted, get squeezed together. Like whatever. Gals that are going to have a baby have contractions. That's the tightening of the muscles and the squeezing of there. I know for sure. Now, so here is what we have to look at here. Right onto the book here, it says this. Let's say you've got this. Here's my coordinate system here. Let's try that again right here. Here's my coordinate system here. I will draw some lines on here. And, you are not allowed to do this because you just can't do it very good. Let's say you have a triangle. Let's say you have a triangle that goes from here. Let's say it's this triangle. Here's my triangle. And it ends up going to here. What type of transformation is that? Next, Christ? Yep. It just slid. It didn't get spun. It didn't get reflected or rotated or whatever there. It's a translation. But if you were asked to describe that translation, sorry. If you were asked to describe that translation, how would you say that shape has been moved? In order for the shape to go from where it originally started out to where it ended, what has happened to it? It was translated what and what, Elijah?
Right to point zero.
Yeah, you have to think about this. You know this point matches up with that point. How did this point go from there to there? Well, you went, it doesn't matter how you say it, you went up to and you went over to. You went up to and you went to the right to. That's how it was translated. It slid up and over, or over and up, it doesn't really matter. What else do they ask you there? Or, how about this? What if I was going to rotate this, rotate 90 degrees to the right around the origin? What would my new shape look like? What would your new shape look like? Well, first of all, here's the origin. What are we doing? We are spinning it 90 degrees in this direction. So how does that work? What you really have to think about is think about this point and this point. If I spun it 90 degrees, which means it made a right angle, a quarter of a turn, that means this point would end up being right here, would it not? So now this bottom leg right here is this leg. This point right here, what happens to it? It turns a quarter of a turn. Where does it end up? You turn it a quarter of a turn, it ends up right here. And your new points would make a triangle that looks like this. If it was 180 degrees, that means this makes a complete turn all the way down to here. Let's do that in green, shall we? If it went 180 degrees, that's a half a turn from here to here. The origin stays the same. This goes a half a turn, which puts it where? Oh, it started here, so a half a turn puts it here. So your triangle would look like this. A lot of lines there, isn't there? Yes, Mr. Hunt, very much. Let me see what they want. Take a look at page 174, please, just so we have a good idea here. Look at letter E, F, and G. Letter E, F, and G, just so we're all on the same page here. Just so you know what it means here. It says, first of all, to sketch rectangle rectangle PQRS is dilated with a scale factor of 3, forming the new rectangle P prime, Q prime, R prime, S prime. Okay, sketch rectangle, well, and here's what the deal would be. If it's a scale factor of 3, what does that mean, Isabel? You're starting off with your first rectangle that looks like this, right? And that rectangle is, what do they give you? P, Q, R, and S, right here, right? P, Q, R, and S. What are the measurements of that? It is 6 centimeters by 4 centimeters. If that is dilated, if the scale factor is 3 times, where's Brianna sit? What does that mean? That means every measurement gets multiplied by 3. So instead of this side being 6, it's going to be 18 centimeters. Instead of this being 4, it's going to be 12. When it asks you to sketch the new rectangle, what that means is this. You're going to make this one 3 times bigger. And P prime goes with this. Q prime goes there, R prime goes there, and S prime goes there. Where's Riley? Riley, I think you sit over there, next to Grace. And how long would the sides be? This side would be 18 centimeters, and this side would be 12 centimeters. I think that's amazing, is it not? I thought so. Band people, well, nobody said Luke. Luke, you can sit next to Isabel right there, it's fine. Alright, for tomorrow, like I said, I probably wouldn't have given you nothing, but so many people did not use rulers and such.